Hello, everyone, and welcome back. My name is Mr. Cobalt, and today we are going to go over a limiting reagent or reactant problem. And so, in this problem, they are giving you the balanced equation, and they give you two amounts of both of the reactants. So, in this case, the problem is asking you to find the theoretical yield, and all they've given you is the balance equation, and they also give you an amount of each of the reactant in mass, grams. And so the question is, well, which one is going to produce the least amount? So you can recognize this as a limiting reactant problem because they don't tell you anything about that you've got enough of one reactant to completely react with the other one. So they don't give you anything, no information about that. They just kind of throw uh, two amounts at you, one of one reactant and one of the other reactant, and say, find the theoretical yield. That's a dead giveaway that this is a limiting reactant problem. And so you need to at least test to see if you've got the same, if you're going to get the same amount from each reactant, or if you have enough of each reactant. So maybe you do, maybe you don't, but you have to test it out first. So the way I like to do this, there are those two methods, and the method that I like to use in this sort of problem is to just take the two reactant amounts and convert that to the desired amount here. And the desired amount here is how much ammonia are you going to get? So find the theoretical yield of NH3. So basically, since you have to find the theoretical yield anyway, that's what they're asking for. So you might as well just convert both of these into the theoretical yield and see which one gives you the lesser amount, and then that's going to be the theoretical yield. And so you've killed two birds with one stone. So let's try that. So I'm gonna take both of these and I'm gonna convert them to masses of ammonia. Now you don't have to convert all the way to mass for both of them. You could stop at moles and compare the mole amounts, and then go from there. So we could try that as well. So the first step is you need to convert both of these to moles. So let's start with NO. So I have 86.3 grams of NO. I'm going to put it over 1. And then I got to use the molar mass of NO. And the molar mass is already calculated here. So NO, the molar mass is 30.01 grams per mole. So I have 30.01 grams of NO to every 1 mole of NO. So now the grams of NO cancel out. And so then I keep going. I have moles of NO, and I want to get to NH3 because that's what they're asking for. And so at this point, I'm going to use the mole ratio between NO and NH3. So I have 2 NO to NH3, so it's 2 to 2 ratio. So I'm just going to write that down. So I have moles of NO, so 2 moles of NO on the bottom because I want it to cancel out with NO, moles of NO on the top. And I have 2 moles of NH3 on the top. So moles of NO cancel out. And now I have moles of NH3 here. So I can calculate the moles of NH3. So if I do that, then I get 86.3 times 2 divided by 30.01 divided by 2 equals, and I get 2.8757, 2.8 757, and that's going to be moles of NH3. And now I can do the same thing with this amount of hydrogen and see how many moles of NH3 I get from that amount of hydrogen. So I got 25.6 grams of H2 over 1. And the molar mass of H2 is written here. So you would calculate that from your periodic table. So I've got 2.02 grams for every 1 mole. And so I will go put the grams on the bottom. 2.02 grams of H2 on the bottom, and I have 1 mole of H2 on the top. So the grams of H2 are going to cancel out. So now I have moles of H2. And so now I'm going to convert moles of H2 to moles of NH3 using the mole ratio. So I have 5 moles of H2 to 2 moles of NH3. So I'm going to use that, 5 to 2. So 5 moles of H2 to 2 moles. 2 moles of NH3. So moles of H2 cancel out. And now I have moles of NH3. So now I'm going to calculate that using my calculator. So I have 25.6 times 2 divided by 2.02 divided by 5 equals. And there I get 5.0693. So I get 5.0693 moles of NH3. So now I can compare the amounts of NH3 produced by each of my reactants. And the one that produces the lesser amount is the one that's going to run out first. Because as the reaction is going, right, I can produce this amount of NH3, but as the reaction is going, it's going to hit 2.8757 moles of NH3 before it hits 5. But as soon as it hits this amount of moles produced, I've run out of my NO. So my NO that I'm given can only produce this amount. As soon as I reach that amount, I'm gone. This is gone. So this is going to limit how much I can produce. So this is my limiting reagent. So the NO is my limiting reagent because it limits how much I can make compared to the other one. So this is going to be my theoretical yield, but I'm not done yet because the problem wants the theoretical yield is in grams. Most of the time, they want grams. So now I have to take this amount of moles. This amount of moles. This is my lesser amount, and now I'm going to continue the calculation. So I have 2.8757 moles of NH3, and I can now use the molar mass of NH3 to convert this to grams. So 17.03 grams per mole. So I'm going to put moles on the bottom, 1 mole of NH3 on the bottom, and I have 17.03 grams of NH3 on the top. So moles of NH3 cancel out. Now I have grams, and so I can calculate the number of grams, 2.8757 multiplied by 17.03 equals, and I get 48,973. So 48.973 grams of NH3. So that would be my theoretical yield. I'm not done yet because I need to make sure about significant figures. So I have to go back to what I multiplied and divided by. So to get this number here, so I'm ignoring this because I didn't use this to continue my calculation, so I'm using this here. So when I did this calculation, I got to get rid of the exact numbers. So 2 to 2, my mole ratios are exact, so I'm not going to look at that. So here I have molar mass, I have to look at that, that's a measure. And this is the amount that I started with. And then this is a molar mass as well, so I need to look at that as well. Both of my molar masses are 4 sig figs. So 4 and 4, and then this is 3 sig figs. So the least number is 3. So my answer can only be in 3 sig figs. So I have to count 1, 2, 3. So it's going to be cut off after the 9. I have a 7, so the 9 is going to be raised to 10. So that means that this is going to be, this is going to be 49.0 grams of NH3. So that is going to be my theoretical yield that I would report to the whatever I'm reporting it to. So I hope this was helpful. This is a good example of a limiting reagent problem. Again, you identify it by the fact that they give you an amount of each of the reactants, and then they say, give me the theoretical yield. They don't say anything about like whether or not it's going to react to completion or anything like that. So you have to test. Maybe it is a limiting reagent, or maybe you do have the exact amounts of each that you need, but you don't know. So you have to figure that out first. And so I use the first method where you just take the amounts of each mass of the reactant, and you convert both of those to the amount of the product you want, and you see which one gives you the lesser amount. The one that gives you a lesser amount is the limiting reagent, and then you continue with that amount. Okay, I hope this was helpful. Thanks for joining me. If you like this video, like the video, share the video, make a comment in the comment section. Let me know what you think, and make sure you subscribe to my channel and ring the notification bell. Thank you for joining me, and I'll see you next time.